In this segment, we'll focus on the relationship between member functions and inheritance. And in particular, we'll focus on constructors and destructors. In this example, we have a person class, which contains the private data of name and ID, and a student class, which inherits publicly from person and has the additional data members of major and GPA. So we want to think about how we can initialize the base class members in the student constructor, so the derived class constructor. You'll notice that here we have the student constructor takes a string for the name, an integer for the ID, and an integer for the major. And inside the constructor, it wants to initialize those. But you'll notice that this is not possible. And the reason for this is the derived class cannot access private data of the base class. So this would not be possible. So now we have to think about how can we actually initialize the private data of the base class in the derived class. And one key idea that we have to recall is that when we call the derived class constructor in particular, students constructor in this case, the constructor for the base class has to be called first. So we can use the constructor for the base class. So let's see what we mean. So constructors are only called when a variable is created. So when an object is created. And now, if we want to initialize base class private data members, we can use the constructor initialization list. So just to refresh your memory, what is the constructor initialization list? So it begins with a colon after the constructor, and here our constructor is the name student, and it takes in a string for the name, an integer for the ID, and an integer for the major. And inside the constructor initialization list, we can explicitly pass parameters to the constructor for the base class. So here the base class is person, and the constructor takes in a string for the name and an integer for the ID, so we can just pass those parameters directly to the constructor for the base class. And when we do that, we will have initialized that private data from the student object, and then inside the constructor for student, the derived class, we can initialize the remaining private data. So when we call the constructor for the base class for our student object, we are allocating and initializing our name, because the student objects will have the name and for the ID. And then we have this memory for the private data for the student object. So we have the major and we have the GPA. And inside the constructor for the student, we will initialize those. So in order to initialize the data from a derived class for any private data members of the base class, we can just use the constructor initialization list to pass parameters to the constructor of the base class. The constructor of the base class is going to be called in order to allocate the memory, the private data members for the derived class. So this is an important takeaway, is that when a derived class is created, instantiated, the constructors for the base class is going to be called before its own constructor. And we can see in the circle, so first it would, if we're trying to instantiate a grandchild class, it would first call its base, the grandparent class, then its parent's class constructor, and then finally be within the constructor for the grandchild. So we don't explicitly call the base class. They're implicitly called when we explicitly call the derived class's constructor. You can explicitly call it in the initialization list, which was the example we had just done when we actually passed the parameters to person's constructor within the initialization list. And it's just important to remember, and this is the key idea, is that the constructors are called from the base class to the derived. And this makes sense because we want to make sure that we're allocating all of the data members and functions that the base classes have, because the derived classes are adding onto that in most cases. Now for destructors, the situation is reversed. And what I mean by that is that destructors are called from the derived class to the base class. So the derived class destructor is called first, and then automatically the destructors for its base class would be called. So it goes from the grandchild's destructor to its parent's destructor to its grandparent's destructor. And this happens automatically. Now, in order for us to see what is happening with this, we can actually go through a trace. So we're going to very carefully go through a trace of when constructors and destructors are called. So we have here 3 classes. We have class A, which we can consider the base class, class B, which is the parent class, which inherits publicly from A, and then class C, which we can think of as the grandchild class, which inherits publicly from B. And you'll notice that in order to figure out when constructors and destructors are called, you can actually add print statements to your constructors and destructors just to see when they're going to be called. So these functions don't really do much, you can see, because all the classes are basically they just have an integer. And we're just really trying to look at when their constructors and destructors are going to be called. Okay, so now we are going to trace through main and trace through every constructor and destructor that is being called. Okay, so now let's go through main, and then I will go through the printout. So first we say, oh, for the B1 object, we would print out we're allocating a B object, and then right here, line 1, we allocate our B object B1. When we do that, first the constructor for its base class A is called, and then the constructor for itself B is called. So here is just a result of creating B1. So here's where we're instantiating B1 on the stack. Next, it says we're allocating the first C object, and this I'll label as line 2. We are creating a new C object called C1, referenced by the pointer to it, called C1 on the heap. And what we're doing is, you'll notice that C1 is the grandchild class. So first, we have to call the grandparent's constructor, which is A, and then we call its parent's constructor, B, and then we call its constructor. And so this is, all of these are the result of creating C1 on the heap. And this, I just want to mention that this is created on the stack. Okay, now we are going to create another C2 object, and we're passing the parameters 4 and 5 to it. So when we pass the parameters, you'll notice that we have in this version of C's constructors, we actually use the constructor initialization list in order to pass a parameter to B's constructor. So let's see what that's happening. So for A, we're not passing any parameter. So the default constructor for A is being called right here. And now for B, you'll notice that we're passing the first parameter, my B, to it. So now the constructor for B that is being called is the constructor that takes a parameter. So that's why we're printing out B4 there. And then finally, we are printing out the print statement from within C's constructor that takes 2 arguments. So here, this is why we print out 5. So these are all the results of creating our object called C2 on the stack. And I just want to mention that in the previous 2 objects for B1 and C1, just the default constructors were being called for all of those. Now you'll notice that we say inside main, we're deleting the C1 object. So when we pass the pointer C1 to delete, we are explicitly deleting that object. And when we do that, you'll notice that the order in which the destructors are called are from the grandchild to the base class. So here, the first destructor is called is for C itself. Then you'll notice we have the destructor for its parent B, and finally the destructor for its grandparents A. So here we have an explicit deletion of a memory address on the heap. So we're just explicitly deleting that object. So here we're explicitly deleting C1. And then you'll notice that the program says quitting, but we're still deleting objects. And the reason for that is that once the program quits, it still has to deallocate all of the objects that were placed on the stack. And the important observation that I want to mention is that stack objects are deleted in the reverse order in which they were created, or destroyed in the reversed object. Sorry, destroyed in the reversed order. And so that's an important thing to note. So now we have to look through, and so C2 was created at line 3. So right here, this is when C2 is destroyed. And when this C object is destroyed, we first call the destructor for C, then the destructor for B, then the destructor for A, and then finally, when we see the destructor for B followed by the destructor for A, that is when B1 is destroyed. Okay, but the key takeaway from this exercise is that constructors are called from the base class to the derived class, and destructors are called from the derived class to the base class. And it may be a very good exercise to spend more time on this to trace through which constructors are being called at which time. Okay. Now, in terms of functions for the base class and the derived class, now it turns out that you can have a function overloaded in the derived class from the base class. And in this particular example, we have 2 versions of compute mg miles per gallon. And those in this example for the car, we just says if the speed is greater than 55, return 30 miles per gallon, otherwise 20. But then for the hybrid, we have a different MPG function, and that is going to return 45 miles per gallon if it's at most 15 miles speed per hour. And if it's greater than 55, it will just return 30. Otherwise, it will return 20 miles per gallon. So when the object is the derived class, so if we have a hybrid object, then the hybrid version of compute MPG will be called. If it's the base object, it will be the base class's version executed, at least for right now, until we get to polymorphism. But you'll notice that the compute MPG function for hybrid is essentially one extra condition and the compute MPG for a car. So if we notice that, you can actually call the base class directly. You can call the base class's implementation directly. And the way that you can do this is just by using the scoping operator. So recall the scoping operator is the 2 semicolons. So you have to give the base class name and the scoping operator. And we use this all the time, for example, when we don't use namespace std, when we have to write std with the 2 colons, this is just the scoping operator. And so here, inside the hybrid compute MPG, we can check if the speed is less than 15 miles per hour, we are going to get 45 miles per gallon. Otherwise, we just have to call the base class's cars compute MPG. So this is a way that the derived classes can call explicitly the base class's implementation of a function, even if it's an overloaded function as it is in this